So today is about sequence and series and finding the nth term of them and then finding sums of them. So let me give you an example. Let's say I had 1, 2, 3, 4, 5. Oh my gosh, that's just adding 1 each time. Would you write an equation for that? You should know how to do this by now. U sub 1 equals and then go from there. Jay, what's the first term?
1.
Okay. And then what do we always put right here? It's called, I call it boilerplate. It's the law name for it where it's like, just gets repeated over and over and over again. U sub, say it. Come on. Classical 5 times faster if you guys would just help out. U sub what? N equals what? U sub n minus 1. U sub n equals U sub n minus 1. That's in every single formula you will ever write for my class. The black part is. This can sometimes be 0, very rarely, but sometimes. All right. Now, I'm going to say what I do to it each time, which is plus 1, but I just made a big mistake. I put it in parentheses. That implies times 1. Do you get if you just times by 1, it won't really do anything? Times 1 just keeps it the same. So no parentheses. Some people say parentheses don't matter. I say they do. You should know that. Okay, and then who remembered n greater than or equal to 2? Raise your hand if you had that one right. Okay, awesome. Pausing for a second. All right, so this gets complicated. There are formulas you've never seen before. This you've seen, but what you haven't seen is how do you, for instance, add up the first 100 terms of that? Would you do it one at a time and just go 1 plus 2 plus 3 plus 4 plus 5? And oh my gosh, that would take forever. So there's a fancy formula for that, and that's what we're going to learn today. You can also even add up infinite sets of numbers. Like how could you, wouldn't this add up to infinity? Yeah, this one would. Because you just keep adding numbers, you'd never stop. But here's the weird one. If you start with 1/2, this will be interesting, I think, if you pay attention for it. You start with 1/2 and you times it by 1/2, then you get 1/4. And you times it by 1/2 again, you get 1/8. And you times it by 1/2 again, and you get 1/16. Do you get we're just adding little smaller and smaller parts to it? The weird thing is, even though we can add up infinite parts, it adds up to a whole number. Now, let me give you an example of that, of me in the room. Try this. Think this through with me. This is cool. So if I start here, you with me? And I go halfway to the door. That's like the 1/2. Would you agree that I have to go halfway to the door again if I'm eventually going to get out that door? And do you get that's 1/4 of the way there? If I go another halfway, that'll be 1/4 of the total way. That's like the 1/2 plus the 1/4. Now, there. Now, would you agree that I have to go half of that? Which is 1/8 of the way. And now I have to go 1/2 of that, which is 1/16 of the way. Do you get the idea? Isn't it weird that I could keep doing that forever, but yet you know I'm going to get to the door? Yes? I know it seems like you wouldn't, but yet see, you're catching on. This is weird. How can you have infinite number of things you add together, but they add to a whole number? But they have to, because if I was 16 feet from the door, for example, I do get to the door. Even if I keep going half of that and half of that and half of that and half of that, eventually the pieces get so small that adding up an infinite number has to end up being a whole number because I can get out the door. So there's a formula for this, and I'm going to teach you that formula in a minute. In fact, yeah, I'll teach it to you in a minute. We have an order for these things, but this is called an infinite sum, and the weird thing is if it's decreasing like this, it adds up to a whole number. How can an infinite number of things add up to a whole number? They can. I'll show you in a sec. All right, this is a simpler one. Find u sub 100. That's the 100th term. Well, there is a way to do this. I don't want you to use the calculator and go enter, 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 enter. You know, it would work, but there's a way, and I'm going to show you the formula for this now. Yesterday, that's all you had was use the calculator, hit enter, enter, enter. But now here's the official way. We use a formula, and if the recursive formula is this, you're just adding 2 each time, right? Then the sequence is this versus the series. What the heck is the difference? Oh, series means you're adding. See the difference? There's no plus signs here. A series, you add them together. That's the difference between a sequence and a series. A series is where you add them up. And so we have formulas that we can use for this. To be honest, I think we'll probably give them to you on the test, these formulas, because they're really hard to memorize. But you got to know how to use them. All right, so here is the formula. It's the big boss formula for figuring out whatever term. You want the nth term, which is like, I don't know, you pick a number, the 64th term. All right, well, in this case, they wanted us to do the 31st term, so let's do that. Do you get it starts at 14? And do you get to keep subtracting 7 each time? So if I wanted to list them, do I really want to list 31 of them? No. 14 take away 7 is 7, take away 7 is 0, take away 7 is negative 7, take away 7 is negative 14. I think you're getting the idea. It could go on forever, but we can actually find the 31st term without doing 31 of these things with this formula. U sub n, which we know, it's 31. U sub 31, copy this down with me now, equals U sub 1, but wait, we know what U sub 1 is. Do you get, they told us what U sub 1 right there? So it's 14 plus n minus 1. What's n again? Remember, that's the n right there. They told us what the n was. The number of terms that they want is 31. So I go 31 minus 1 times, somebody smart, you're going to know what the d is. I'll give you a hint. It's the CD, really. Come on, you can do this. Common difference. Very good. What is the common difference? The difference between each term. Yes, that's the common difference. So, what's hard about this? If they tell you n, you just put that wherever n is. See? There and there. They tell you the starting term, that just goes there. And the common difference, that just goes there. Do you get, if I just gave you this formula and said, here, use the formula, it wouldn't be that bad. You just stick the numbers in the right spots. Let's finish this off. What is 31 minus 1? It's 30 times negative 7. That's negative 210. And I still got to add 14 here. So I'm going to put the plus 14 at the end. And that gives me U sub 31, which is the 31st term. What's negative 210 plus 14? I don't know. What's negative 200 plus 4? So it's negative 196. And there it is. That's what they add up to. No, that's the that is the 31st term. If you had just done this on the calculator, it would have given you negative 196 when you got there. All right, so this is what the test's going to be like. We give you this formula, and then we say, use this formula if U sub 1 is 10, n, which is the number of terms that we want, I want the 20th term, and the common difference each time, I'm going to make you figure it out from what I'm writing. So what's the common difference? What's the difference each time? Did you get positive 10? Positive 10 is the common difference. would you now stick those numbers in this formula right here, right underneath it, and you multiply it all out and you'll have your answer. And it'll be the 10th term. Nope, 20th, sorry, 20th term. If we use the numbers given, we started with 10. The common difference is 10 because it goes plus 10 each time. Do you get this as faster than having to use your calculator and going enter, 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 and then, oh, which one am I on? And I lost track, and it's much better. Okay, so if I stick all these things in this formula, help me. U sub n is U sub the what n? Well, what's n? It says so right here, the 20th term. We're trying to find the 20th term. All right, Sage, what do you think we should put for U sub 1? 10 goes here, plus what goes next? 20 minus 1 times, what's the d? Yep. So then this is 10 plus 19 times 10. That's 190. 190 plus 10, 200 is the 20th term. Does that make sense to you? All right. That's the formula you'd use to find the nth term. I'm going to give you one more, and this should go way faster now that you're getting used to this. Start with 7. Add 3 each time. Find me the 15th term. That's the same as U sub 15. Use this formula down here. Pausing for a second while you stick these numbers into this formula. So here we go. I hope you put U sub n, which is this one right here, as U sub the 15th term, so U sub 15. Is U sub 1 is next. Oh, that's 7. That's U sub 1. And then I go plus, and then I got to go parentheses n minus 1. What's n again? N is the 15th term. That's n. So 15. Whatever term you're finding, that's what n is. Minus 1 times d, the common difference. What was the difference each time? Well, as this kept going from here to here, and here to here, it was adding 3 each time. So that's plus 3. So did you do 14 times 3 and then add 7? Because that was right. 14 times 3 is 30. My brain's locking up. Is that 42? Okay, and then 42 plus 7? 49. Raise your hand if you had 49. Awesome. Then 49 is the 15th term. All right. Now, it'd be awesome if today was done right there, but unfortunately, there's several of them. We just did enough practice on this other kind. But now here's a new formula. You get how that looks totally different than the other formula that we did? Yes, sir.
Will we get the formula on the test?
I think so. I just can't promise you yet because I haven't actually talked to the team, but I know in honors, which is what I taught, last time I taught this, it was in honors. In honors, we even give the kids the sheet with the formulas. So I think you'll probably get it. Okay, so then let's do this one. It's different. Why is it different? Because it's geometric. You're not adding something each time. You're multiplying something each time. So the geometric formula, the U sub 23, that's what I want to find. U sub 23 is, follow me on this and see if you can do it. U sub 1, right here. Oh, it's right there. It's 6. times R, that's the common ratio again. What's the common ratio? Right there. 2.5 is the common ratio. To the power of, ooh, I remember these, at an x in the exponent. These are exponentials. N minus 1. What's n, though? N is, what is n? That's n. The little subscript. N is the subscript. You may want to write yourself that note. Okay, so n is 23, so this is to the 23 minus 1. You could probably do that in your head quick and just write 22 right there. And what would I do first? I definitely want a calculator, because 2.5 to the 22nd power is huge. And then I'm going to times it by 6, and that's the final answer. That's the nth term in a geometric sequence. Why is it so massive? I mean, that's huge. Because you're finding 23 terms later after you keep multiplying by more than 2. If you multiply just by 2, it gets to be massive. You multiply by 2.5, it's insanely massive. So, basically just follow the formula. All right, here's the next formula. And it feels a little crazy, but we have 4 formulas. We have already covered 2. Here's our third one. If you're going to add up a series, then you use this formula. And that stands for sum of. Okay, so for the sum of this series, I'm going to take n, which is, remember, n is the subscript. So this is n. N is 32, so we put a 32 here. Divided by 2. Times 2 times the u sub 1. Well, the u sub 1 was 26. So I'm going to go parentheses 2 times 26 plus n minus 1. N is 32 again. 32 minus 1 is just 31. I hope you can allow me to do that in my head. It was n was 32. I took away 1. I got 31. And the last is d. There it is, the common difference, which is minus 2. So, final answer, 31 times negative 2. 2 times 26. And all that's times by 32 divided by 2. Well, 32 divided by 2 is 16. 2 times 26 is 52. And 31 times negative 2, well, 31 times 2 is 62. And then I got to make it negative, so negative 62. Holy cow, that's a big answer too. I can almost guarantee you calculators are allowed, because if we had to multiply that all out, tons of kids would get it wrong just because of the multiplication. It's just hard. Don't hold your place and stuff. So, okay, so some of the kids checked it with me, and we got negative 51584. That's just me following a hard formula. Do you know what U1 is? It's the first number. What's N? It's whatever term you're looking for. Like in this case, the 32nd term. We're adding up all the numbers in this arithmetic series. This is, again, a sum of arithmetic. This is the exact same formula, so I don't want to torture you with this one twice. Now this is a geometric series. Did you get there's different ones for geometrics and arithmetics? Okay, so let's see what they want here. U1 is 250. That definitely goes somewhere in my formula. Bloop. What the heck is R? Oh yeah, that's R. Right there. To the N, that's the N. The little subscript is the N. That goes there. And then it's just minus 1. All over R minus 1. And we just said that R was this a second ago. That's R. So we put it there. And I'll write it out now. 250 times 0.4 to the 21st. That's because that's the n there. Minus 1. All over the r, which is the 0.4. Came from right there. Minus 1. And you'll have a calculator and you'll type that in and you'll get your answer. But what is it? It's what all of those things add up to. Series is the kind where you find the terms and you add them all up. How many of them? 21 of them. Okay. There's only one more kind. Infinite geometric series. I gave you a taste of this one at the beginning of the hour, and it's actually a super simple formula. So Noah, I think you get the struggle with, like, I want to get out the door and I got to go halfway there, halfway there, halfway there. Is an infinite number of parts. But it adds up to a whole with this formula here. Tell me how far I am from the door. What's your gut feeling? Feet from me to the door. Best guess.
20 meters, maybe.
Okay.
25.
I'll say 20. And if this is 20, my starting distance from the door, and I do that halfway to the door, halfway to the door, halfway to the door thing, then r is 1/2. So if I keep adding all of those up, I start with 20. That would mean my first set of steps was 20. So really, we actually start with our first, or use of 1. On the way to the door that's 20 feet away, do you get, I would start with 10. The first, like the first term of it would be 10. I go 10 feet, and then I go half of that is 5 feet. And so it would look like this. To get to a door that's 20 feet away, I go 10 feet there, halfway there, and half of that is 5 feet, and half of that is 2.5, and half of that is 1.25, and half of that is blah, 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 blah. And guess what it adds up to? 20, because I get to the door. 10 divided by 1/2 is the same as 10 times 2, which is 20. Let's see if you really got that infinite one again. We'll do one more of the infinite kind. Here's that formula again for infinite. Sum to infinity. Let's say that the first part of my journey to the door had been 8 feet. And then I keep going half of that. So 4, half of that. 2, half of that. 1, half of that. 1/2. And then I keep adding up this infinite series. It'll equal a whole number. Please put in, what's u sub 1? JP, what's u sub 1? The first term. Right there. 8 is the first term. 1 minus r. The ratio is like this. 4 divided by 8. 2 divided by 4. Noticing a pattern? 1 divided by 2. Oh my gosh, they're all 1/2 is the ratio. 8 over 1 minus 1/2. That's 8 over, what is 1 minus 1/2? It's 1/2. And 8 divided by 1/2 is 8 times by 2 over 1, and that's 16. If my first set of steps was 8 feet to the door, then the total must be 16. Couldn't you just double that number? But that's assuming we always go half. So here's how this formula would be handy on your test, because we're not likely to make it as nice as you're 16 feet away from the door. How many feet is it to the door? Will it be 16? But here's how you could use this formula with a more normal problem. You start with 1/2, and you keep adding half of that, half of that, half of that, dot, 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 U sub 1 is your first term, so that's a half. And what's happening each time? Times a half. And it ends up being 1 minus a half is a half. Half divided by half is 1 whole. Now again, I kept on doing the multiply by a half thing, but you could multiply by 1/4. And then this r would have been 1/4. All right. So here's our 4 formulas. That was one of the toughest lessons you've had in a while. But it isn't that hard if you know which formula you got to use. So if I were you, right now, please, in a moment, you're going to take a screenshot. I'll even do it myself. So I'm curious if video keep going while I'm taking a screenshot. Take a screenshot of these because you're going to need them and you're allowed to have them. And it'd be really nice for you to be able to just look back in your pictures whenever you're like, oh, what are those formulas again? Oh yeah, I took a screenshot. So I want to push these 2 buttons on my iPad. And apparently the video just keeps going. That's cool. So I've got that saved for later. Do you see that if you had the formula sheet, it won't be that bad? You'll be wondering things like, what's U sub n? That's the term you want, like U sub 25, 25th term. What's U sub 1? It's always the first term. What's n? That's the subscript. Like in U sub 25 or U sub 6, it's that. The little number that's a subscript at the bottom. And that's called the common difference. All right, you've had a lot of cushy, easy days today. Today was a rough one. A lot of formulas. It's a Schoology quiz. I encourage you to start on it now. Totally understand if you don't finish it before we leave today, but then do it for homework. That's all I got for you for today.